Hi, this is Doug Brown, author of Tracker. In this tutorial I'm going to show you how to track video features using the Autotracker, which can mark points automatically. It's not only faster, but also often more accurate than manual tracking with the mouse. I've organized the tutorial into 3 sections: how to use it, how it works, and how to control it for best results. So let's start with how to use the Autotracker. First, you have to have a video to track, and I'm going to use this one from Live Photo, in which a ball rolls off the edge of a table. It's a good video for auto tracking since the background's nice and uniform. Now we're going to use a point mass track to represent the ball, and I've already created one and named it ball. But as you can see, it doesn't have any positions marked yet. The data table is completely empty. Now to use the Autotracker, we have to open it up, and there are 2 ways to do that. We can choose the Autotracker menu item from the ball's track menu here, or we can click on the Autotracker button up here on the toolbar. In this case, the Autotracker has already selected the ball as the target to be marked, but if it hadn't, you could select it yourself by choosing from this drop-down list. If we look in this message area, we see instructions that tell us to create a keyframe by Shift-Control clicking a video feature of interest. So that's my next step. I'll hold down both the Shift and Control keys at the same time, and then click near the edge of the ball. This creates a circular template image for the Autotracker to match in each frame of the video. You can see the outline of the template on the video here where I clicked it. It's the circle. And over here on the Autotracker itself, you can see the template image magnified by a factor of 2. Now all we have to do is click the search button. And that's all there is to it. Okay, so now let's look in detail at how the Autotracker works. I've opened it up again, and we're looking at the keyframe. I've hidden the actual points themselves so that we can see the Autotracker overlays without any interference. I've zoomed in on the video by a factor of 2. And if you remember, I held down the Shift and Control keys, got that circular cursor, had a little crosshair in it before, and then I clicked here to create the keyframe. Well, when I did that, you can see that it created 3 graphical elements. It created this circle, which defines the template up here, but it also created this rectangle with a dotted line around it. That's called the search area. And then the third thing that it created was this little crosshair in the middle, and that's called the target. So with those 3 elements in mind, here's how Autotracker works. First, it looks at every test image that's in the search area. Test image is going to have the same shape and size as the template, and it finds the RGB difference between that image and the template image. Second, it looks for the image with the lowest RGB difference, and it identifies that one as the best match. Third, it determines the match score for that best match. And then fourth, it takes appropriate action, for example, marking a point at the target position. Now let's talk about the details in each of those steps. First, as far as searching for the test images in this search area, a test image is defined to be in the search area if its center is in the search area. So as you search, and occasionally when you find matches, you may find that the image actually extends, the edge of the image extends outside the search area. Next, the RGB difference between a test image and the template is defined as the sum of the squares of the differences in the individual RGB components as seen in this overlay. Now, it's important to notice that all of the pixels in the template are included in this RGB difference. So every pixel counts, even those in the background. This is a lot different than visual matching because, unlike your brain, the Autotracker can't really interpret the image in any way. Now, here's how a match score is defined. It's basically the mean RGB difference of all of the test images divided by the RGB difference of the best match image. And then we subtract 1 so that a match that's no better than average gets a score of 0. Finally, the Autotracker takes an appropriate action, and there are really only 2. If the match score is high, it accepts the match with confidence and marks the point at the crosshair target. If not, it pauses for user intervention. Now let's talk about how to control the Autotracker. I'll also make some recommendations to help you get the best results possible. First thing to look at is the video itself, since that's the raw data. First of all, always set the video clip properties like the start frame, step size, end frame, frame rate, and so on before you use the Autotracker, so you only have to search the frames you really want to look at. And don't forget that you can apply video filters when you need to, especially things like perspective, radial distortion, and resize filters if you have any distortion issues. If you're shooting your own videos, which I highly recommend when possible, there's a lot more you can do to make auto tracking more successful, and here are some of the most important things. First, use a uniform background that contrasts with the object to be tracked. Second, use uniform illumination. That can make a big difference. Third, use a fast shutter speed so moving objects don't get blurry. And fourth, avoid any motion toward or away from the camera, which makes it difficult to calibrate the video. Now let's look more closely at the template image. I've zoomed in a little bit here so we can see it better. This circle shape is just the default. You can drag this handle here to change the size and shape, and you can drag the edge to move it to a different position. Now you don't want to make a really huge template because it slows it way down. Remember, it's comparing every pixel, so a smaller template's always faster than a big one. I'm going to go back to a smaller template for the next section. Okay, let's take a look at the template settings over here on the Autotracker itself. The first one is the evolution rate. See, the template isn't really a static image, but instead evolves over time by blending in the matches. This can make a big difference when there are gradual changes in the lighting or background. Now let's take a look at how the template image changes as I step through the video. Initially, the ball's kind of a dark gray with a reflective highlight. But as I step forward, I see that over time, the template becomes lighter and more uniform gray, and that's because that's what the matches look like. The change is gradual, of course, because it's using this 20% default evolution rate, which means that each new template is made by blending 20% of the match image and 80% of the previous template. If the evolution rate were 0, the template would never change, while if it were 100%, each template would be the previous match. Just for comparison, let's go back to the beginning, delete the points, set the evolution rate down to 0, and do another search. See, this time there was enough of a gradual change in the ball and the background that it got to this point here where it didn't find a good match, and so it paused for user input. You can see that a little bit of evolution can make a real big difference. You want to be careful, though, not to make the evolution rate too high, because that can result in template drift, where the real object you're trying to track drifts relative to the center of the template image. The second template control is the auto mark level here that determines the minimum match score for which the Autotracker will mark the point automatically. If we review the match scores, that we got with this fixed template, we see that early on, here we had a match score of 27.7, 31.5, 23.3, and so on. But as I get farther down here, they start to get lower. Here's 8.8, 8.9, 7.4, 7.1, 5.1. Whoop, and then see it went down to 2.7, fell below this auto mark level of 4, and that's when it paused. The default auto mark level is 4, but you can raise it if you want to make sure only really good matches are accepted, and you can lower it if you're willing to accept matches that are only fair. Okay, here are my recommendations for the template. Smaller is better, faster. Try to track corners and edges when you can. If anything's rotating, be sure you're tracking a circular feature. And you can increase the evolution rate when you need it, but do be careful about drift. Okay, now let's look at how to control the search area shown by the dotted line rectangle here. Again, you can resize it with the little handle in the corner, and you can drag the edge to move it around to a different place. In general, you don't want it to get too big or it slows down, and you don't want it to be too small or the match you're looking for may fall outside the search area. Now, unlike the template image, you can drag the search area in every frame, not just the key frame. So let's search forward a few frames here. And we see that the handle's still visible. We can still drag it anywhere I want. Notice too that when I do that, this search this button up here becomes enabled. So I can always do a new search in a particular area if I want. For example, if I search right now, it doesn't find a match. If I drag it back here, search again, and it does. Okay, now over here on the Autotracker, there are two checkboxes that can help you further control the search process. One on the right is labeled Look Ahead, and when it's checked, as it is by default, then the past positions of the track are used to predict where the future match is going to be, and the center of the search area is moved to that position. If instead it's unchecked, then the search area is simply centered on the previous match. Let me show you what I mean. Up to this point, we've been searching with the look ahead turned on, and so it's been using these previous positions to predict where the next match would be, and in this case it moved the search area so that the center of the search area was at that predicted match position. If we turn off the look ahead and search for the next frame, let's see what happens. See, the search area was not moved to the predicted position at all. It remained centered on the previous match image, and then it did the search. In this case, the search area was big enough that it still found the match it was looking for. The important thing is that when you're tracking objects that move with a fairly uniform acceleration, this look ahead feature can do a good job of predicting future matches and allow you to use a much smaller search area than would otherwise be the case. On the other hand, if the object never moves very far from one frame to the next, turning off the look ahead feature may work just as well. Okay, the other checkbox is labeled X-axis only, and when it's checked, then the search is restricted to the X-axis where it passes through the search area. The main use for this is when you want to track the motion of an edge. So to see how it works, I've opened this video of a membrane being struck by this funny looking projectile. When I do a normal search, watch what happens. It's able to find matches and it tracks the edge, but it jumps up and down kind of crazily, and that's not really what I want. So if we go back to the beginning, delete the points, check this X-axis only box and do the search again, we see that we get a one-dimensional search, and that's exactly what I was looking for. Okay, here are my search recommendations. Do use smaller search areas when you can. They are faster. As long as the acceleration is fairly smooth, use the look ahead option. And when you're tracking a linear edge of some kind, limit your search to the X-axis. Okay, let's look at the target. The target actually refers to two related objects. The track point to be marked, shown over here, and that can be any point on any track, including the origin and X-axis handle, for example, on the coordinate axes, or even the corners of a perspective filter. And then it also refers to the crosshair over here, which can be anywhere you want. It doesn't have to be at the center of the template. For example, if I move it up here and then I search the next frame, I see I get a match here, but it's been marked up here. Okay, now let's look at what happens when the Autotracker can't find a good match. It does show us some options. We can accept the match if there's a possible match that's been found, as in this case, there's a button down here we can do that with. We can always modify the search area and search again. We've already seen that. I can shift-click as usual to mark the point manually. I can step back and define a new keyframe, and that's a pretty important option. We'll look at that in more detail. And as a last resort, I can hit this skip button down here, which skips this frame and continues on to the next one. So let's try a couple of these. In this case, it's a pretty good match that it found, even though it didn't automatically mark it. So I'm going to accept it, moves on to the next one, does the same thing again. Maybe I'll do another accepting there. Let's see, at this point, just for a difference, I'm going to hold down the Shift key and mark this manually. It moves on and looks at the next one. In this case, it doesn't find an option, it doesn't find a match at all. So let's back up a couple spots here and go back to this point here, for example, and hold down the Shift Control keys and make a new keyframe. Right? Notice how the template now represents that new keyframe. And if I start searching forward from that point, it actually does a much better job at finding additional matches. Now, pay close attention to the cursor when you're creating new keyframes because it shows you what you're actually creating. Here I've cleared everything out so we can start fresh. And if I hold down the Shift Control keys, we see I get a cursor that has a little crosshair in the middle of it. And that tells us it's going to create a new crosshair target at the same time that it creates a template and search area. If I step forward now, searching as I go, I get to a point here. Let's try making a new keyframe at this point. If I hold down the Shift and Control keys, now I get just an open circle. There's no crosshair target in the middle of it. And if I click, I get a new template and a new search area, but notice that the crosshair target hasn't moved. And so now if I continue to search, see that the crosshair is now still where it was, and that allows it to continue to mark points in a consistent way along the track here. Now when you do create new keyframes, this Show Keyframe button is useful. When you click it, it shows you all the frames where there are keyframes, and you can go back to any keyframe that you want to review that and make changes if you need to. Okay, now recall that I described the skip button down here as a last resort. There's two reasons for that. First, if you skip a frame, the Autotracker won't be able to look ahead, and it may end up searching the wrong area of the video. And second, if you're marking a point mass in particular, then just one missing position will result in 3 missing velocities and 5 missing accelerations in the data table. So it's really always better to mark every frame as you go. Well, that's it. Now you're an expert Autotracker. Happy tracking. Bye-bye.